Welcome back to the Physi Key, guys, and in today's video we will discuss about one of the concept of class 9 physics chapter 10 gravitation, and the topic is motion of an object under gravitational force of earth. This topic basically can be understood using these 2 points. First point is the type of motion and gravitational acceleration. Second point is equation of motion under the gravity. So let us start the session. Let us discuss first point of the concept is the type of motion and gravitational acceleration. Here, when object moves over surface of the earth, it experiences force due to the gravitational force of the earth. That means that whenever the object moves, it is always under the influence of gravitational force of the earth, and the direction of gravitational force of the earth is always toward the center of the earth. As we know from my previous video that this force is called weight force of an object. So because of this weight force, the object is always under the gravitational acceleration. As you know that from the Newton's second law of motion, whenever there is a force, there will be an acceleration. So when object moves, it is always under the influence of the gravitational acceleration of the earth, and the direction of the gravitational acceleration is towards the center of the earth. So basically there are two types of motion under such condition. One is the motion of an object in vertically upward direction, and second, motion of an object in vertically downward direction. And generally the second kind of motion is called free fall. Okay, so let us discuss the first kind of motion, that is a vertically upward motion. Okay, here I have shown the diagram of the vertically upward motion. In generally what we have seen in our daily life, whenever there is a vertically upward motion of an object, motion is generally thrown from the surface of the earth, okay, in upward direction. So consider this person is throwing a m mass object on upward direction, and in that condition the throwing speed or throwing velocity is considered be initial velocity u, and it will be always in the upward direction. At this condition, at point of throwing an object, the gravitational acceleration is always towards the downward direction. After reaching some height, what will happen? The object will be slowed down due to the opposite direction of gravitational acceleration, and due to which its velocity is gradually decreases as it goes away on the some height. Ultimately, whenever it will reach a maximum height, and at that time it will be momentary at the rest, and that's why the final velocity in the upward direction will be 0. Still, there will be a gravitational acceleration in the downward direction. So when an object is thrown vertically upward with initial velocity u, then the gravitational acceleration ge will be in the downward direction. So for motion of an object, direction of motion of body is opposite to the direction of the gravitational acceleration. So as I have shown here, you can see that the direction of the motion of the body is in upward direction, and direction of the gravitational acceleration is on the downward direction. So basically what you have to consider is the direction of the motion of the object and direction of the gravitational acceleration of the object. Basically for this case, vertically upward direction, both are opposite to each other. So after traveling vertical height, object will be slowed down, and at a particular maximum height its motion will be stopped. So at the maximum height, velocity, final velocity will be equal to 0. Here in equation of motion, a acceleration will be replaced by the gravitational acceleration ge, but with the negative sign. That means that the negative sign showing that the direction of motion and direction of gravitational acceleration is opposite to each other. Okay, so here we have to take value of g minus because of this opposite nature of the direction of the gravitational acceleration as well as the direction of motion. So now what are the modifications which require to state the equation of motion under this vertically upward motion? So v is equal to u plus at now will be replaced by v is equal to u minus ge into t, where value of g can be 9.8 meter per second square or can be taken as a 10 meter per second square. The x is equal to ut plus 1 by 2 at square now changed to h is equal to ut minus 1 by 2 ge into t square. Okay, so here basic concept is that a has to be taken minus, and the last equation v square minus u square is equal to 2as will change to v square minus u square is equal to minus 2 ge into h. Here s is replaced by gh because here the distance covered is equal to the height attained by the object. Now the second kind of motion is the vertically downward motion. In this condition, the person is dropping an object from some height, and whenever before downward motion the object has a zero initial velocity. Also, when the object reaches the ground, it is possessing some maximum amount of velocity. So when object is dropped from the height h, it moves toward the ground with the initial velocity u is equal to 0. Okay, because it was dropped from the stationary condition. U is taken as a 0 because the object initially before dropping was in the rest condition. Now here for such a motion, if we see the direction of motion and direction of gravitational acceleration, then both are in the same direction. So direction of motion is also in the vertically downward direction. I have shown it by the green arrow, and the direction of the gravitational acceleration shown by the black arrow also in the same direction. So under such motion, object will eventually reach the ground with the maximum speed or maximum velocity. That's why final velocity for the vertically downward motion will be equal to maximum velocity, that is Vmax. Okay, so in such condition, equation of motion will be changed like this. Here the replacement of acceleration is with the positive value of gravitational acceleration, that is 9.8 meter per second square, or sometime it is 10 meter per second square. Here positive sign is because that the direction of gravitational acceleration and direction of motion both are in same direction. So v is equal to u plus at will be now changed to v is equal to u plus ge into t, or v is equal to u plus gt. X is equal to ut plus 1 by 2 at square now change to h is equal to ut plus 1 by 2 get square, or 1 by 2 gt square. V square minus u square is equal to 2as now changes to v square minus u square is equal to 2 ge into h, as s is replaced by height and x is also replaced by height. The second point of the topic is that equation of motion under the gravity. Here I have bifurcated both the discussion with this green line. Okay, so for freely falling motion, that is a vertically downward motion, these are the set of equation of motion after this replacement of gravitational acceleration, okay, and height. So v is equal to u plus ge into t, h is equal to ut plus 1 by 2 get square, v square minus u square is equal to 2 ge into h. On the other side, vertically upward motion, since the gravitational acceleration direction and direction of motion both are opposite, so these are the set of new equations. Now here we know that for the vertically downward motion, freely falling body, u is equal to 0 as well as g is equal to 9.8 meter per second square. So putting the values of u and g here, we will get v is equal to 9.8 into g. So the equation 1 become v is equal to 9.8 into t, as value of u is 0. Value of u is 0. Second equation will h is equal to 1 by 2 9.8 t square, as again ut term will be 0 because of u is equal to 0. So if you will cut this wheel, it will become h is equal to 4.9 t square. And the third equation, v square minus u square is equal to 2 ge into h. Since u is equal to 0, so v square is equal to 2 into 9.8 into h. So v square is equal to 19.6 into h. You can directly memorize this equation, three equation, and you can directly use in the numerical part as well. But if you are not able to memorize it, you just memorize these equations. Vertically upward motion, for vertically upward motion, value of velocity is equal to 0 and the gravitational acceleration is 9.8 meter per second square. So putting here the first equation, v is equal to u minus ge into t, become 0 is equal to u minus 9.8 into t. As final velocity is 0, so v is equal to 0, that's why u become 9.8 into t. Second equation, h is equal to ut minus 1 by 2 get square will become h is equal to ut minus 1 by 2 value of g 9.8 into t square. Okay, so h is equal to ut minus 4.9 into t square. Third equation, v square minus u square is equal to minus 2 ge into h. 0 square minus u square is equal to minus 2 9.8 into h. So minus u square is equal to minus 19.6 into h. So u square is equal to 19.6 into h. So these are the set of equation for the vertically upward motion. You can directly memorize it, or you can just memorize this equation and you can make these set three equations. If you like this content, if you are liking my way of presentation, do like this video, share this video, and don't forget to hit the subscribe button. Till then, let us meet in my next video.